This is Dr. Bahauddin Abdullah, and this is section 9.4, Multiplicative Inverses of Matrices and Matrix Equations. Let us start by the multiplicative inverse. First, I'd like to define IN. We mean by IN the multiplicative identity matrix of order n. The main diagonal, all the elements in the main diagonal will be 1 and all other elements would be 0. This matrix is called the multiplicative identity because when you multiply this matrix I by any other matrix, either from the right or from the left, you get the same matrix A. And that's why we call it multiplicative identity matrix. This is I2 and this is I4, and you can write I3 and I5 and whatever you like. It is a square matrix, 2 by 2 square matrix, and this is n by n square matrix. Now this symbol A inverse is reserved for the multiplicative inverse of A. And by the multiplicative inverse of A, we mean the matrix A inverse, in which when we multiply A inverse by A, either from the right or from the left, we get the identity matrix. So if you multiply A by A inverse, you get the identity matrix, which is this one or this one. Depends on the size of A. Now let us have an example. Determine whether B is the multiplicative inverse of A. So this is the matrix A and this is the matrix B, and the question, are these two matrices inverses of each other? How to find out? We should multiply them. If their product is the identity matrix, then they are inverses of each other. So let us multiply A times B, find the product. If you remember, we multiply the first row by the first column, the first row by the second column, the second row by the first column, and the second row by the second column. We get the identity matrix. If we also multiply B times A, and if you remember, we know that AB is not necessarily equal to BA. Well, in this case, they would be equal. So this is a special case because their product is the identity matrix. So if you multiply B times A, if you start by multiplying this row by this column, and so on, you will get also the identity matrix. So these matrices A and B are inverses of each other. So we don't mean by A inverse 1 over A. There is no thing like 1 over A, but there is A inverse. Okay. Now this is a method to find A inverse. This is a rule, a way to find A inverse. If this is A, this is A inverse. 1 over AD minus BC multiplied by the same matrix, but AD we replace them and we keep BC, but we multiply by negative sign. So for example, if this is the matrix A, how to find A inverse? 1 over AD 12 minus BC minus 10. So it's 1 over 2, and change for 3, change positions, and here change signs. And now this is 1 over 2, multiply 1 over 2 times this matrix, you get this matrix. So this is A inverse. And if you just go to the previous example, this is A and this is B, and we proved that these two matrices are inverses of each other, and here we know now how to find A inverse. But this method is used only if A is a 2 by 2 matrix and if AD minus BC is not 0, because if it is 0, then A inverse does not exist and A has no inverse. If A inverse exists, we say that A is invertible matrix. Now, how to find A inverse in general for any n by n matrix? Well, we write A like this, and we write a vertical bar, and then we put the identity matrix here. And then we use the 3 transformations we know before to change A to the identity matrix, like we do in Gauss and Jordan method. And while we changing A to IN is also changing, and it's changing to A inverse. So let us see an example. This is a matrix A, and the question find A inverse. So we write this matrix A here, and vertical bar, and the identity matrix. And let us now change this matrix to the identity matrix, Gauss and Jordan. So this is 1. I need these numbers to be zeros. So these are the two transformations. R1 plus R2 will make this 0. Minus R1 plus R3 will make this 0. And these, all of these, now the first row will remain the same, but the second and the third row will be changed. Now we have 1, 0, 0. So I need this element to be 1. Either I divide by 2, or this is negative 1, so I'll just replace R2 by R3. But still it's not 1, it's negative 1, so multiply by negative 1. So now it is 1. Now use it to change these two numbers to zeros. This is 0 already, so I need to change this to 0. Negative 2R2 plus R3 will make this 0. So this row will be changed. And now this is 1. We are lucky to have this as 1. So we just use it to change these two numbers to zeros. Negative 2R3 plus R2 and negative 2R3 plus R1 will change these two zeros, and will also do some changes here. So we will get to this matrix. Now this is the identity matrix. So this is A inverse. This is the inverse matrix. The last point in this section will be how to solve a system using A inverse. If you have a system of matrices like this, you can write it in this form, AX equals to B, like here. So A is the coefficient matrix, 1, negative 1, 1. These are the coefficients of X, coefficients of Y, coefficients of Z, multiplied by the variables X, Y, Z, equals the constant term, 6, negative 5, 6. 6, negative 5, 6. So you have this matrix, A times X equals B. Now how to solve this system? How to find the values of X, Y, Z? Well, this is the answer. Find A inverse and then multiply A inverse times B, you get X. So to solve this system, AX equals B, find A inverse and multiply by B from the left. So X would be A inverse times B. Lucky we found this A is the same matrix here. So we already found A inverse, which is this one. So I will use this in A inverse to multiply by B, and I will get X. So X is A inverse times B. Just multiply these two matrices as usual. This row times this column. Then this row times this column. This is 3 by 3 and this is 3 by 1, so the result would be 3 by 1. So X is 4, Y is negative 2, and Z is 1. And that's the solution of this system using A inverse. Good luck.